Hey everyone, in this video I just want to go over the topics in section 2.8, starting with the distance formula. The distance formula involves 2 points, so we've got the point x1, y1, and the point x2, y2. So that could be something like, I don't know, 2, 6, and the point, we'll make this 5, 10. The distance between these 2 points is you take the change in x, x2 minus x1, you square it. You take the change in y, you square it. You add these two together, and then you take the square root of it. And this, if it looks familiar, is absolutely a form of the Pythagorean theorem. It's just the Pythagorean theorem in disguise. For our example, this would be, let's see here, 5 minus 2 squared plus 10 minus 6 squared, and then the square root of all of that, which is, let's see here, 3 squared plus 4 squared. Aha. 3 squared plus 4 squared, you mean 9 plus 16, or we're looking for the square root of 25, which is 5. So the distance between these 2 points is 5. And if we go ahead and we mock out some axes here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I find 2, 6, 2. So 1, 2, 3, 4, 5, 6. Here's 2, 6. And I find 5, 10. And this is over 3. So 1, 2, 3. Here's about 5. 1, 2, 3, 4. Here's 10. This is the hypotenuse of a triangle. It's the hypotenuse of a right triangle, so it's totally just the Pythagorean theorem to find the distance between 2 points. Now, we might not always be able to have it be so neat and clean. Like I could have negative 2, 3, and 4, 6, and I could find the distance between those 2 points. Let's see here. The distance is square root of 4 plus 2 squared plus, let's see here, 6 minus 3 squared. We find the square root of all of that. So that's 6 squared plus 3 squared. That's the square root of 45. So it's not clean. Square root of 45, that's 9 times 5. So this is 3 square roots of 5, right? And it's not always clean. It's not always even. But it's always going to be greater than or equal to 0 because we're squaring some values. So even if I mess around and I get something negative, like, oh, I don't know, negative 2 minus 4 squared plus 3 minus 6 squared, that'll be negative 6 quantity squared plus negative 3 quantity squared, or still 36 plus 9 square root of 45, still 3 square roots of 5. And that's what we really need for a distance. Distance has to be greater than or equal to 0. What about a midpoint? So to find the midpoint, it's very nice. 3, 2. The midpoint of a line segment, not a full line, but a line segment, is very nice and logical. So let's grab the points that we're working with here. Negative 2, 3, and 4, 6. I'm going to take and find the average of my x values. So what, like 4 plus a negative 2 and divide it by 2. 2 divided by 2 is 1. That's halfway between my x coordinates. I do the same thing with my y coordinates. I take 6, I add 3 to it, I divide by 2. 9 over 2, let's call it 4.5. So what's the midpoint? 1, 4.5. So the midpoint formula is x1 plus x2 divided by 2 is my x coordinate. y1 plus y2 divided by 2 is my y coordinate. So if I want to find the midpoint of -3, 7, and I don't know, 5, -11, that would be, call it the point M, equal to 5 minus 3 over 2, comma, -11 plus 7 over 2, which is 2 over 2, and -4 over 2, so that's 1, -2, and that's our midpoint. Next topic, let's look at circles. The standard form for a circle is sometimes called HK form, because we take x and we subtract from it h, and then we're going to take y and we're going to subtract from it this value k, and we're looking at the sum of these two values, and that's equal to the radius squared. This h right here, this is the x coordinate, and this k right here, this is the y coordinate of the only point that really matters in a circle, the center, and then r squared is, of course, the radius squared. So if I had x minus 1 squared plus y plus 1 squared is equal to 9, okay. The x coordinate is going to be 1. The y coordinate is going to be -1. The radius is 3. So if I draw my axes and I want to draw a circle, I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. I'm going to go to x equals 1, y equals -1, right there. There's the center of my circle. My radius is 3. 1, 2, 3. There's the one edge. My radius is 3. 1, 2, 3. There's the other edge. 1, 2, 3. 1, 2, 3. There's my circle. And that's the standard form of a circle. So here's a graph of a circle, and what I'm going to do is we're going to take this graph of the circle and we are going to find the equation of it. So I'm going to look for about the middle of the circle. I've got this mark as a reference. This is a reference. Right here. This is the center of the circle, and that's at, let's see here, y is -2 and x is 2, halfway between 2 and 4, so 3. So this is 3, -2, and the radius is, let's see here, so this is 1, 2, 3. The radius is 3 wide, so r equals 3. So this is the absolute value, or x minus 3 quantity squared plus y plus 2 quantity squared is equal to 3 squared, or 9. Okay, let's look at another one. This is a little bit different, but again, I'm going to look at the edge right here. I'm going to look at the edge right here, and my height is 0. I can see that the height is 0. So that's 0, and then for the x, it's -2, -2, 0. So it's the quantity x plus 2 squared plus y squared is equal to whatever the radius squared is. So 0, -1, 0, 1, 2. So that's 1, 2, 3, 4. The radius is 4, so the radius squared is 16, and that would be the standard form, the equation in standard form for that circle. Okay. Now, in addition to standard form, circles could also be expressed in what's called general form, and that's where everything is all expanded out. And dare I say it, ugly. That would be something like x squared plus y squared plus 6x plus 2y plus 6 is equal to 0. What I'm going to do to rewrite this is I'm going to grab all of my x stuff and write it over here. X squared plus 6x. I'm going to grab all my y stuff. I'm going to write it over here. Y squared plus 2y. What about the 6? I'm just going to leave it out for now. And now I'm going to complete the square. So I'm going to take 6, I'm going to divide it by 2, and I'm going to get 3. I'm going to take 3, I'm going to square it, that's 9. So I need to add 9. So we're going to plus 9, which means over here I've got to add 9 too on the other side. I'm going to do the same thing for the y. I'm going to take 2, divide it by 2, I get 1. I'm going to take 1, I'm going to square it, I'm going to get 1. So that means I need to add 1. So I'm going to add 1. I'm going to add 1. Now you'll notice my method right here is kind of just ignoring that 6. And that's fine. We'll subtract it over. So let's get rid of it. Let's make that not 10, but we'll go ahead and we'll say minus 6 minus 6. So this should be 10 minus 6 or 4. Okay. Now, this is a perfect square. This is x plus 3 quantity squared. This is a perfect square. This is y plus 1 quantity squared, and it's all equal to 4. Hey, we just rewrote this in standard form. So, how did we rewrite it in standard form? By completing the square twice. And what's the radius? Square root of 4 is 2. So the radius here is 2, and the center would be at -3, -1. Cool. That's it for this video. I'll see you next time.